Good morning, good afternoon, and good evening, everyone, depending on where you have joined from. We still have a few attendees joining in as we speak. We will just get started with a quick introduction. My name is Balrama, and I'm your host today. First, thank you all for registering and taking the time to join us today for this webinar on 4 things you need to know about modern data lakes. Before we get started with the session, I have a few housekeeping announcements. To help us have this meeting in a more effective manner. At any time during the webinar, please feel free to ask questions by typing them into the questions or chat window on your screen. The questions will be answered at the end of the session. Following the webinar, the recording will be available and shared with all the attendees. If you experience any technical issues, please visit the help menu in the GoToWebinar control panel on the right side of your screen. And lastly, I have placed all of you on mute for a better meeting experience. To give you all a quick background on Appstick, we provide customized IT consulting services for companies ranging from mid-size to Fortune 100 enterprises across a wide range of industry verticals. We leverage agile practices, and our SMEs, architects, and associates build software applications, platforms, and products that become the primary drivers of innovation and revenue growth for our clients and their businesses. Appstick is recognized for driving quality and speed to market when business success depends on the software applications. We were founded in 2007 and headquartered in Addison, Texas, with offices in USA, Middle East, and Hyderabad, India. Coming to introduce today's presenter, Parag Penkar. Parag Penkar is Global Delivery Head and Vice President, BI and Advanced Analytics at Appstick, and focuses on technology solutions and delivery excellence for our clients. He has over 25 years of experience in software development and consulting and is passionate about delivering great customer experiences and business value. Prior to joining Appstick, Parag was a Director of Solutions Architecture at Zeloni and also served as a practice head and technology leader at leading Indian IT services and consulting companies. He has an engineering degree and a master's MMS in marketing from SVKM's Narsi Monji Institute of Management. I will now hand it over to Parag to walk us through the session today. Parag, the stage is yours.
Thank you, Balram. Good morning and good evening, everyone. And thanks a lot for joining in. My name is Parag Penkar, and I'll be talking about 4 things that you need to know about modern data lakes. And how do you derive value by building use cases on top of your data lake platform? But before we get started, let me talk about an article that I came across recently from Gartner. What is data worth to your business? And there are many questions that come up, from an organization's perspective. We need to understand what data is all about. As we know, data is an enterprise asset. Many organizations are looking at innovative ways of using the data to create value, take timely decisions, and remain competitive. Organizations need to ensure that no data is turned away, effectively make use of data to address challenges that lie ahead of them. Data-driven organizations typically have data culture embedded in them, which percolates from the top and is ultimately made available to anyone and everyone who needs it and can act on it. This way, new ideas emerge and operating improvements are made. But organizations should also ensure that they improve data literacy by providing their employees the required training and the right access to tools. They also need to go in for data monetization. Data monetization, in fact, should be embedded into the business strategy by putting the right structures in place. I'll give you an example of a telecom data customer where we implemented a data lake about 3 years back. Within 3 months of going live on the data lake platform, they were able to create a 360-degree view of their customer, which was a fantastic opportunity to improve services and then to monetize the data externally. They also went went in for data monetization for location-based analytics, where they could target customers with new offers. Organizations need to ensure high data quality, privacy, security, and ensure proper governance policies are in place. Data Lake is actually a sophisticated platform and can help organizations derive value for making better business decisions. This slide actually talks about the significance of data lakes and how they can be used to answer the questions that are mentioned on the slide. Going forward, let's discuss about the agenda that we have for today. The first thing is about the traditional and modern data architecture. The second, on the maturity model the organizations need to go through. We then come to the challenges and complexities involved in building data lakes, and finally, the characteristics and benefits that data lake provide. I will also take you through some of the case studies at the end of the presentation in terms of how we have actually helped organizations derive value from their data lake platform. So let's get started with the differences between a traditional and a modern data architecture. When you look at a traditional data architecture, you're actually building data warehouses using structured data with limited data sources and volume. Typically, 60% of the time is spent in building complex rigid ETL transformations, which is the most time consuming and the tedious part of building a data warehouse. Reporting is stale because data is not real time, but it rather depends on the refresh rate of the data warehouse. The refresh rate could be weekly or at worst even monthly. So let's understand, how does a modern data architecture look like? On the other hand, if you look at a modern data architecture, you have data lakes at the core because of the flexibility they provide. Using data lakes, you can practically ingest any data from any source. There are no limits to the amount or variety of data. Data lakes provide an inexpensive storage, are scalable and agile. With data lakes, you can perform any number of real-time, inexpensive queries on your data. You can connect your data lake to a reporting tool using JDBC or ODBC connectors to develop reports and dashboards, or to build advanced analytical AI and ML models. You can even connect your data lake to a data warehouse and carry out the operational reportings from a data warehouse if that's the business requirement. In this way, you are leveraging the investments which are made by the organizations on the data warehouse, as well as if you need to ingest any new data from a new data source, you would do it through a data lake and thereby avoid complex ETL transformations. So let's understand what are data lakes. Data lakes are central to the modern data architecture. Organizations are modernizing their data architecture, and as data types and volumes grow, data lakes kind of become a cornerstone to their digital transformation journey. Organizations need a system that is agile, time to insight is shortened, and importantly, it provides a scalable platform for storage and processing of data. Let's look at what data lake and the structure looks like. Data lakes scale horizontally. They store data on a cluster of nodes, and you can handle any volume of data using low-cost traditional hardware. You can ingest data from any structured data source like your ERP, CRM systems, your transactional systems basically. Semi-structured source, which includes your XMLs, your emails, any other data formats like JSON, etc. Unstructured data, which is like your images, videos, or social media content. You can ingest data at rest as well as in motion, that is batch and streaming data. You can partition your data into different zones, and we'll talk about data zones a little later during the presentation. You can capture metadata and then ease of searching and browsing through your data lake, which will actually help you track and give governance for your data lake. You can query your data lake as well as provide access to third-party reporting tools. A data lake essentially can be built on-prem, on the cloud, or there could be a hybrid combination. It actually has a storage layer that we just talked about, as well as a compute layer where you do essentially your processing of data. Then you have a data management layer where you track data and lineage, apply security and privacy, build workflows, and carry out any other governance activities. And finally, you can use data for reporting or advanced analytics. So that's how the structure of a data lake looks like. So this is something which every organization has, and I wanted to talk about this a little bit in detail. When you look at an enterprise data landscape, you talk from an IT and a business perspective. In any organization, you'll have an IT team as well as you'll have a business users. IT team typically gets involved in building the data management platform that utilizes the ecosystem of open source tools to operationalize your data lake. This includes managing ingestion of data at scale, capturing metadata, improving data quality, transforming data, and securing it. Organizations are also looking to leverage their investments in enterprise governance applications. But the key component of the modern data platform is what you see there, the data catalog and the self-service capabilities that allows business users to ingest data that is relevant to them, prepare the data, and then use leading BI and visualizations tools that access the big data platform. The key here is governed self-service and the data platform's ability to integrate and leverage the existing data management infrastructure of the organization. So that's how it actually happens, you know, the work that the IT team does, the work that the business users do as far as building a data lake is concerned. Now let's get to the data lake maturity model. There are several stages of maturity an organization goes through while implementing the next generation data architecture. An organization would always want to know at what stage of the spectrum it is, what are the challenges in that stage, and how do you transition from one stage to the other. Organizations who are actually in the first stage primarily rely on structured data. They use data warehousing technologies that has been built over decades. They do not wish to change. They are very slow to accommodating to business changes, and that's what we call the ignore stage. Then there are organizations who use data lake only as an inexpensive storage, and then you have siloed pockets of analytical insights without having a good handle on what's in it there, resulting in a data swarm, and we call that as a store stage. But the actual stage where the organizations would like to be in is the govern stage, where you have full visibility of your data and lineage. You can apply security and privacy. You can implement rules and workflows. You can address data quality on where the data is stored and how it can be accessed. A govern stage actually sets you up for a more advanced data environment, which typically helps your business users for self-service ingestion and provisioning. You can build advanced analytical AI and ML models, moving towards an intelligent data lake. and nicely occupying the automation and the optimization part of the maturity stage. And that's where organizations are moving from a governed and a managed data lake to something that we call as a self-organizing data lake. So let's understand what are the challenges of building a data lake. We know that data lakes provide data for analysis, and they can do it in a agile and a cost-effective way. But building a data lake is complex. You have a data lake which can be built on-prem. You have a data lake which can be built on cloud because of the growing emphasis towards the cloud. You can have a hybrid combination, and then there are multi-cloud capabilities. But there are no defined standards for metadata management and governance, and the big data system is constantly evolving and fragmented. Research says that 70% of the organizations do not have big data skills to implement a data lake in-house. And then organizations would want to integrate that data, their modern data, with old mainframe legacy systems, and that becomes a challenge. And then there are organizations who would actually start off with, for building a proof of concept, moving towards a governed and a managed data lake, but they are not able to scale up. And that is one of the reasons why 80% of the data lakes fail to make it to production. If you look at it from a business perspective, how do you then use your data lake for personalizing customer experience? How do you address regulatory compliance and reporting requirements? How do you build advanced analytic AI and ML models? These are the reasons that you need services of an organization who has the right skills, prior experience in building data lakes by adopting best business practices, helping you in your digital transformation journey. And that's where we come in. So these are some of the common data lake use cases. If you look at it from a customer 360 perspective, it's pretty much a universal use case where you can talk about building insights of data coming in from different data sources. We'll talk more about the customer 360 in the case study section of the presentation. Fraud detection, typically common across banking, financial services and insurance, energy and utilities, telecom, and so on. Regulatory compliance, again across BFSI, healthcare, and telecom. And then reporting and advanced analytics pretty much across all the industry verticals. We have got good experience and expertise in implementing a few of these use cases for our customers. So let's come to what it takes to build data lakes. The first stage in building a data lake is obviously ingestion. You ingest from files, streams, and databases. You can ingest from the cloud, local machines, FTPs, or REST APIs, and you can completely automate the ingestion processing framework. Essentially, you're identifying your data sources and creating automated, repeatable data pipelines. This actually ensures you to know what is there in your data lake. Once you have done the ingestion, you move towards organizing. That's where you capture metadata for ease of searching and browsing. So essentially, you are tracking end-to-end data lineage. You're seeing how the data moves and how it is consumed in the data lake. You safeguard data and reduce risk, knowing from where the data has come in, where it is, and how it can be accessed. You inventory raw data and you ensure high data quality and privacy. Once you have done the organization part, is then you come to the enrich part, where you transform the data as per business use cases. Now that's the difference, that a data lake brings in over a data warehouse. In a data warehouse, you would have to extract, transform, and then load the data into the data warehouse. When you talk about a data lake, you first extract, load, and transform the data which is required for your business use cases. You create workflows and you enrich the data which is specific to your organization's lines of business. For example, sales, marketing, purchasing, HR, manufacturing, and so on. So you are essentially managing the data preparation process. And then you actually extract the data in any format to the tool of your choice. As we discussed earlier, you can connect to third-party reporting tools through ODBC. You can generate reports and dashboards, and you can create advanced analytic AI and ML models on top of your data lake. So these are the steps that you actually use to create a data pipeline. Now let's look at a data lake reference architecture. On the left-hand side, you see various data sources. Typically, your relational data stores, your logs, your sensors from your IoT devices, social unstructured data, and so on. You will typically have the data which is file-based, database-based, ETL extract, streaming, or in the form of APIs. Essentially, you will be putting it into the transient landing zone. This is something like your staging area, where you will perform basic data operations before which the data gets loaded into the raw zone. Raw zone would therefore have your original source of data, but you would definitely not want to give the entire organization access to the raw zone. And therefore, you will tokenize your data, mask the data, and store it into the trusted zone. And this becomes your single version of truth. Then you may take the data from the trusted zone, enrich the data, and create a refined zone, something that we discussed for organizations' lines of business. Or you can create sandboxes where some of your users, like your data scientists, can do any ad hoc exploratory analysis on your data. All along, you will do metadata management. You will provide the necessary quality to the data because it may not be in good shape. You will build a data catalog so that it becomes easy to search for your data, and most importantly, the security part of your data lake. So essentially, you are ingesting the data and provisioning the data in the data lake so that it can be consumed by your data consumers, which could be business analysts, researchers, data scientists, and they can use any third-party tools like Click, Tableau, Power BI, Python, or whatever you call it to build the required models. So let's understand now the benefits of a data lake. The first benefit is managed ingestion, which is discovering and managing data in any format. We have seen we can do batch and streaming ingestion. You can do database ingestion with support for full and incremental updates. You can capture metadata and governance. Now, when you talk about metadata, we talk about three different kinds of metadata. Operational metadata, which actually talks about how the data comes in and how it is transformed in the data lake, which is essentially your lineage. Technical metadata in terms of the data type, formats, number of records, and so on. Business metadata, what it essentially means to the business, and so on. So that's what you do from a metadata management perspective. Workflows and orchestrations. You create workflows not only for building ingestion pipelines, but also for transforming your data. In which case, your data lake needs to have a robust workflow management feature with scalable and extensible architecture. Your data may not be always in good quality, so you would do data profiling, validation. You will build essentially a rule tools engine for data quality. You will do data quality reporting and analysis. You can even do automation of the data quality remediation process. You will then go to security and access control, where, as we discussed, you protect sensitive data, tokenize masked data so that you can give access to required people within the organization. You actually can even give access to certain data lake artifacts like the entities that you build in, or data quality rules, and so on. The next is when you talk about a data retention. You would not always want to have all the data in the data lake. You would want to actually create different kinds of data lifecycle management. Something like a hot zone, a warm zone, and a cold zone. Hot zone will have all the data that is frequently accessed, let's say for 30 days. A warm zone could be data that is accessed over 90 days. And a cold zone could be, something that could be accessed over 7 years or so on. All depends on your policies of the organization. You would want to do data integration, connecting it to any reporting tools or any giving access to enterprise applications using REST APIs. And finally, you would want to do data enrichment and self-service. Any kind of operations on the data, like drag and drop features, sometimes a little bit of data wrangling if possible. And you would want to have self-service ingestion and provisioning so that your business users can actually do certain operations without relying on the IT team. So that's what the data lake benefits you can see. Let's get into the components of a data lake. We talked about data lake on-prem and we talked about data lake on cloud. So I would want to give an understanding of what it takes to build an on-prem data lake and what it takes to build a cloud data lake. If you look at the on-prem, at the below, you will see different data sources. So these are not only your transactional systems. It can be data coming in from your data warehouse, from clickstream, social medias, logs, images, videos, IoT sensors, GIS data, any of these data. You would want to actually ingest the data into your data lake. And that can be in a batch mode, a real-time, or a near real-time mode. You can use various ecosystem components of Hadoop to ingest that data. For example, streaming data can be handled using Kafka or Flume. Relational data through Scoop. You can use Storm. You can use NiFi and many other tools to ingest your data into the data lake. And that's where you see a data lake sits on your Hadoop distribution and offers all the benefits that we talked about. And then you are actually creating different partitions, as we saw in the data lake reference architecture. A raw zone, a trusted zone, a refined zone. Again, by no means this is a hard and fast rule that you need to create only these 3 or 4 zones. It essentially depends on your business requirements. You would create sandboxes for doing ad hoc exploratory analysis of data. So essentially your data sits on HDFS, which is your Hadoop distributed file system, or a NoSQL database like your HBase. And then, as we saw in the data lake structure, you have a compute layer. So you would process the data, and that processing is done using Spark or MapReduce. And then you would have to access the data from the data lake. So a Hive is a SQL data warehouse that sits on top of your Hadoop and then accesses the data. You can actually search the data using Solar. You can do any kind of processing on your data, as we discussed earlier, before the data can be accessed by your data consumers. Your enterprise applications accessing data in the form of APIs, your BI reporting tools in the form of R, Python, or any of the other tools, data scientists. If you look at the modern data architecture we discussed about, a data lake connecting to a data warehouse, and that's where you have a data warehouse as well as one of the consumers. You can actually have a data warehouse, take the data from data lake and do an operational reporting if that's a business requirement. So these are the components of an on-prem data lake. Let's see different kinds of cloud data lakes that we have. The first one is the AWS data lake. Again, you have different data sources. You would actually want to ingest the data so that it can be stored in the storage layer. So you have a storage gateway service which can extract the data and store it into either an S3 or an EFS, which is your elastic file system, or Glacier, which is your low cost storage. You have Glue, which is your extract, transform, and load tool. You can use Kinesis for your streaming data. You can process the data as we discussed using Hive, Elastic, MapReduce, another tool for processing your data. You can have Athena, which you can actually write SQL queries to access your data. And if you have any custom codes that you would want to run to process your data, you can do it using Lambda. And then again, you have the serving layer, which will typically access the data, and it can connect to your data visualization tools like Python, or Kibana, QuickSight, which is something similar to a Tableau or a Power BI, or a machine learning kind of studio. You have Redshift, which is again a data warehouse. So if you have a requirement to extract the data from the lake and put it into the Redshift, you can do that. RDS is a relational data store, and DynamoDB is your NoSQL database. And all along, you will have AWS Glue, which is your data management and governance layer. The next one is your Azure data lake. More or less the same thing, but I thought I'll just cover this very quickly in terms of your sources, different ways in which you can ingest exactly like your AWS, depending on which platforms that the organizations has. They can actually decide to go in for the required technology. You can use Azure Files for ingesting file data, Azure Data Factory, Event Hub for streaming data. You can store it into an Azure Data Lake store, blob storage, and so on. Again, the same thing, Hive, HD Insights, very similar to your Hortonworks data platform on Azure, where you can actually process the data, and streaming analytics to process any kind of streaming data. And similarly, it can be accessed through Python, R, and so on. So again, you have a SQL data warehouse, which is your serving layer, a SQL database, Cosmos DB, which is your NoSQL database. When you're talking about Azure, you have Power BI as your reporting tool, and you can use Azure ML Studio, a fantastic way to actually create a lot of drag and drop AI ML applications using Azure ML. It actually provides you with a notebook service like Jupyter. You can run your R and Python codes using Azure ML, and come up with any kind of advanced analytical models. And then you have the Azure Data Catalog, which is your data management and the governance layer. And lastly, just wanted to talk about the Google Cloud Platform as well. So you have again the sources. The ingestion happens through different sources. So again, you have PubSub, which is your publish and subscribe. You have a Google data flow for ingesting your streaming data into the storage layer. You have for manual initiated transfers, you can use a command line interface like a GSUtil, or you have a storage transfer service for transferring your data from on-prem to cloud, or from one cloud to the other cloud, and so on. And ultimately, you can store the data in your cloud storage. You can actually store the data even in BigQuery, and then kind of query it. You can use Hive on Dataproc to actually process your data. And there are multiple ways in which you can process your data. And then of course you have the serving layer. So again, you have the Cloud SQL, which is your database managed service, similar to a Cloud Spanner, which also does the same thing. You have a Cloud Bigtable, which is your NoSQL managed services, Cloudfire, which is used for your web and mobile database, and so on. And at the end, you have Looker, which is your BI and analytics platform for deriving analytical insights, Data Lab, which is essentially your similar to what we have seen for Azure, a Jupyter notebook book service, and it comes with a lot of data science libraries, including TensorFlow and NumPy, and then Data Studio, which is your reporting tool. And all along you have the data catalog, which is your data management and governance. So basically, these are the ways in which you can actually build data lakes on-prem or on cloud. When you look at all these components on the cloud, does not mean that you need to use all of these components. That's where typically the implementation partner would come in, understand your business requirements, and decide, depending on the platform of choice, what are the tools required to create a data pipeline, transform your data, and then create various visualizations and analytics for you. So as we discussed, we come to the case studies of data lake. How do you actually build value on the data lake platform is by actually implementing business use cases to derive the value from the platform that you have implemented. Now, one of the things that we saw in common use cases was typically on reporting and advanced analytics. You can actually connect a data lake to any of your reporting tools through ODBC connectors and develop reports and dashboards. But that's the normal reporting and analytics. When you're going a little further, when you talk about a lot of data which is coming in, that's where you typically look at it from an advanced analytics perspective. It is essentially the machine learning techniques that help you build model to achieve a specific outcome depending on your business use cases. Now, when you see here data coming in from everywhere, how effectively you use the data depends on the models that you create. There are different analytical approaches. Again, these are not a comprehensive list of approaches, but some of the approaches that we have used to create different kinds of model. If you look at probabilistic matching, it is mastering different records to create a golden record. We'll talk about this in the next slide. The second one is data clustering. When you say you want to group customers having, let's say, similar purchasing habits. Classification techniques, when you identify a group of customers who would churn or maybe default on a loan. Rule-based algorithms, which will help you predict a particular outcome based on findings. Example, a doctor will prescribe medicine based on the symptoms that he sees in the patient. And then reinforcement learning, which is a goal-oriented learning based on interaction with the environment. Some of the analytical approaches there are many more, but let's talk about now a few case studies. The first one is the customer 360. A specific use case that we implemented for a large retail customer who was into beauty, fashion, and gifts, for a data lake that we implemented using Azure and HD Insight. What we did was we ingested data from different sources, we transformed the data as per business rules, we mastered the customer records, created the golden IDs, and then stitched the data coming in from your transactional systems like your ERPs, point of sales, to create a customer 360 store. Now, once you have an understanding of customer 360, then you can carry out a lot of other things for the customer. You can then have specific campaigns with targeted marketing offers, intelligent pricing and offers, or even customer behavioral analytics. But before I go there, this was done actually using probabilistic matching. So what we did was we took the attributes like the first name, the last name, the email ID, the phone number, and then we used probabilistic matching to create a cluster of records and then identified the golden record from there. So that's how the whole customer 360 store was set up. And then when you talk about customer behavioral analytics, you can actually build a lot of KPIs, to determine who are your high value customers, what motivates them to buy more, let's say best time to reach out to them, they would attrite, what is the best time, I mean, when would they attrite a specific brand and so on. The second use case that we actually did for a telecom data lake customer was on churn. So essentially, one of our customers was facing problems due to attrition. They wanted to determine the reasons that attribute to customer churn and then take actions. Run marketing campaigns to provide different kind of offers to the customers who are likely to churn and thereby retain them, and then minimize the loss of revenues due to customer churn. So essentially, what we had was we had few data sets from the customer. One was on customer demographics, which was basically on gender, like male and female, and the age, like senior citizens, middle-aged people, teenagers, and so on. We had billing information, which was your monthly and annual charges that they were paying to the telecom company, the payment method. We had product services like if they have subscribed for a telephone line, a broadband line, security, streaming services, and so on. And then, of course, the customer relationship variables, which is like your tenure and contract period. So what we did was, the first step was we formed customer clusters based on demographics, which was gender and age. We had data from the customer in terms of who are the customers who had churned over the last 6 months. We developed a model and trained the model to identify the attributes for churn and find out the correlation between those attributes. Once we did that, we then used the model along with the new data set that was provided to identify customers who are likely to churn in the future. And then customers who had, let's say, a 70% or more probability to churn, specific marketing offers were sent to them to minimize the possible loss of revenues. When I was talking about correlation between the attributes, these are the things that we observe. Customers with additional services like security, backup, protection, tech support, and streaming services were likely to churn. Customers were less likely to churn. Customers who would renew contract on a monthly and higher monthly charges are more likely to churn. And then we provided them offers like monthly discounts, combo plans, etc., to retain them. The next one is a market basket analysis, where typically, again, a retail data lake customer of ours, so he was a large distributor of home appliances and wanted to sell products to retailers who would stock these products based on customer demand. So normally what used to happen is that a salesperson from the distributor would go and recommend products each time he visits a retailer based on some manual analysis done internally. They wanted a system wherein, based on similar customer groups and their purchasing history, they are able to recommend new products and help increase their revenues. So again, as you see, it was a 5-step process. The first one was customer segmentation. So basically, we actually generated customer clusters based on customer groups like supermarkets, hypermarkets, electronic shops, all of whom would stock the home appliances. Then we ran a machine learning algorithm to generate customer recommendation based on association rules. When we ran that, it would actually give a recommendation on what are the products that has to be recommended to the retailer. And then we interface this with the mobile UI, because the salesperson had a mobile app that he would carry to actually recommend these products. So if you look on the right-hand side, it talks about basically entering a customer ID, and then first it will show you all the products that the customer has purchased, and then against each of the categories like kitchen and home appliances, computers and accessories, electronics, what are the customers and what are the products that could be recommended. The algorithm that we develop could also be modified to take seasonality into account. So in case your going towards like certain seasons like Christmas or a new year, you know that there will be likelihood of like people coming and buying more from the retailer. So the algorithm could actually be extended to score items based on seasonality. Sometimes it also used to happen that some of the products from a retailer could go out of stock based on the last few days of the month, let's say on 27th or 28th, in which case the algorithm could even identify and recommend items that, okay, for this item you need to purchase higher quantities so that you do not come across a stock out situation like this. So that was the thing which we did for a retail data lake customer. So the next case was on the conversational AI. So basically, it was a banking customer where we wanted to implement a conversational AI. The whole idea was to improve customer service and, most importantly, context switching and memorizing conversation. So normally what happens is if a customer calls a bank and he gets connected to a bot, he would get answers based on the details that he would ask the bot related to financial statements, account balances, if he wants to do some transfers and so on. So this bot is more of a Q&A bot. But what we wanted was developing a conversational AI who would actually go one step ahead to perform spell checks and expand on abbreviations. For example, if a customer mentions CC, it means that it's credit cards. So let's take a scenario where a customer is talking to the bot and he's trying to initiate a transfer from one account to the other. And suddenly the customer realizes that he needs to pay his credit card bill. He would ask the bot to kind of take him and pull out the latest credit card statement and facilitate payment. The conversational AI will take him to that part, pull out the statement, facilitate payment for him, and at the end of the payment, he would actually do a memorizing of the conversations and ask the customer, I think you stopped where you were planning to transfer from one account to the other. Would you want to continue with that? And as a result, the conversational AI could take care of both the things. In case the conversational AI or the bot is unable to answer the query, the platform had the capability to transfer the chat to a human assistant along with context and history, so that the customer does not have to provide all the info all over again. So that was the conversational AI. So what basically we did was that when you look at implementing use cases on your platform, these are some of the case studies that we have done for our customers. We talked about a normal descriptive analytics, which is purely reporting analytics using any of the third-party reporting tools. We talked about churn, which is a predictive analytics. We talked about market basket, which is a prescriptive analytics, and we talked about conversational AI, which is a cognitive analytics. So the complete chain of advanced analytics is what you can implement using your data lake platform. And then this actually talks about the different cognitive use cases that we have developed as a part of the expertise that we carry in this space. This is for healthcare, for manufacturing, for financial services, and as you could see, it's like more on detection of diseases specific to some of these ailments. The whole idea of talking about this is using deep learning model using neural networks, and the data that we use were like your scans, your x-rays, blood reports, and so on. Similarly, for manufacturing, predictive maintenance, again deep learning using CNNs, which is your convolution neural networks, and then data that we actually use was sensor data from equipments. And then for financial services, similarly for stock prices and forex and so on. Again, data was unstructured data from websites. So basically, these are some of the use cases that we have developed. This is not an exhaustive or a comprehensive list of use cases. There are many such use cases that you can develop using AI and ML modeling. and kind of derive value depending on the business requirements of the customer. The whole idea was to talk about an end-to-end journey, right from data lake implementations to building various advanced analytical models for organizations to realize a faster ROI and take informed business decisions. So just a quick recap, traditional versus modern data architecture. Yes, we discussed traditional is data warehouses, modern is data lakes. Maturity model that our organization goes through, the different models, like we start from ignore and then data swamp and then governed and managed, automation and optimization, ultimately moving from a governed and a managed data lake towards a self-organizing data lake. Challenges and complexities, why it is difficult to build. Constantly big data system is evolving, a lot of things are coming into picture, and as a result organizations are finding it difficult to do it unless they have those skills or even personalize it from a business perspective. And then the characteristics and benefits of data lakes that we talked about in terms of managed ingestion, metadata, data quality, REST APIs, I mean integrations, enrichments, and so on. So that's all what I have for today. I'm sure you have got the entire gist of the 4 things that we need to talk about modern data lakes, and then completing your journey with the help of building use cases on top of your data lake platform. So I'll now transfer it back to Balram to actually see if there are some questions that I can answer.
Sure. Thank you, Parag. That was very insightful. At this time, I would just like to remind the attendees that to ask any questions, you can do so by typing them into the questions window on your screen. We have a few questions coming in, and if others want to ask questions, you can do so by typing in the chat window. So Parag, we have the first question from one of the attendees. So what are the key considerations that organizations need to take into account while planning their data lake implementation?
Sure. Thanks a lot, Balram. I think this is a very good question and a very relevant question. It's important for organizations before they plan to implement data lakes in terms of having a few considerations, only then to start the journey for data lake implementations. According to me, I think the first would be to concentrate on business objectives and not technology. The organizations need to do a kind of a cost benefit analysis of why they want to build a data lake, what is the essential reason or the purpose of building a data lake, what data they essentially want to extract from the data lake, and what are the governance policies that they are following right now and what they would want to follow once the data lake has been implemented. The second part, I think, could be on the data protection and security. A lot of organizations today would be definitely adhering to certain compliances. It could be GDPR, it could be HIPAA compliance, and so on. They would want to know if your data lake can actually help you address those compliance requirements. So that's the second consideration that probably organizations would like to have. Also, from a security perspective, what are the data zones that we discussed? How the organizations would want to give access to the data to different people within the organization. So essentially, it means role-based access controls. Today, what's also happening is that with the advent of technology, like cloud, automation, management, and so on, there are different technologies available. We saw the components of on-prem, AWS, Azure, Google Cloud, and so on. So that's another consideration coming to a technology area in terms of what technology to use, how to use it, what are the various data sources the organizations would want to consider, what kind of data they would expect from these data sources. any considerations on the data quality, data integration, data retention, in terms of like retaining data, into different zones and stuff like that. And finally, I think making the data lake business ready in terms of, having a data catalog, uh, having a complete data lineage of how your data comes in and gets transformed, and then the data enrichment capabilities of the data lake, and providing your business users with a lot of self-service capabilities so that they can carry on the operations without reliance on IT. So I think these are the four considerations: business objectives, protection and security, the technology considerations like cloud, and making the data lake business ready is what I feel.
Thank you, Parag. We have another question coming in. This is one of the hot trending topics currently in the field of data. So the question is Snowflake also considered as data lake?
Well, that's a good question again. Yes, I mean, Snowflake is not actually considered as a data lake. I mean, Snowflake is like, when you are actually providing a data warehouse as a service. So essentially, today, the way, I think a lot of organizations are moving towards Snowflake is that they are seeing actually Snowflake being implemented on top of your data lakes, because data lakes, when you actually extract the data, you would definitely get into some kind of latency issues and stuff like that. When you take your data from the data lake and send it across into Snowflake, the way the entire architecture of Snowflake is concerned, it will have your virtual compute virtual warehouses. Each will have a different compute power, and you would be able to actually get insights more quickly. So a Snowflake ideally would sit on top of your data lake and would probably give you faster and better insights.
Okay. Here's the next question, Parag. I mean, moving away from the technical stuff. So the question is, who owns a data lake business case? Is it the business or IT?
Well, okay, that's a good question as well. It actually depends, on the organization, to be very honest. Now, based on the experience that I had in implementing data lakes for a few customer of ours, I would say essentially it is the IT who owns the implementation of a data lake, because that was one of the reasons why I showcased that slide on, if you remember, the data lake landscape, the clear segregation between IT and the business team. The reason why IT owns the data lake use case is because essentially the data lake platform will be implemented by the IT team, taking into consideration the managed data ingestion, the data quality, security, transformations, and so on. But having a data catalog, providing self-service ingestion capabilities is something that the data lake should actually give out, and that's where the business users would want to come and actually do a lot of transformations on the data rather than waiting entirely on the IT team. So I would say that essentially it is owned by the IT team, but it has to be, as I mentioned in my earlier answer as well, that it has to be a business ready data lake where the business able users should be able to do self-service ingestion, able to prepare the data and then extract it using any of the reporting tools.
Okay, we're getting close to the top of that. So maybe just the last question, Parag. So what are the typical timelines to build a data lake?
Well, okay. There is no direct answer to this question, but yes, I'll definitely throw some insights in terms of what are the timelines. The timelines to build a data lake essentially depends on two things. One is whether you're building a data lake on-prem or you're building a cloud data lake. Now, why I say that is because when you're trying to build a data lake on-prem, then it is essentially setting up the data platform. You will need the hardware infrastructure, depending on what is the data volume that you need to consider. So you will have to determine what is the size of your cluster. And then you would also have to consider the different environments, like the development test, pre-prod, or any of those. And then, of course, if it's an on-prem, then you would want to do a Hadoop installation and so on. So essentially, it would take about, let's say, 3 to 4 weeks for setting up the hardware infrastructure, doing the Hadoop implementations, and then kind of your environments, and then if it is required, you want to Kuberize the environment and so on. So that could be the case, and then it becomes ready for ingestion of your data pipelines. So data pipelines typically would take time depending on how many data sources, what you want to achieve, and so on. So ideally, to give an answer, it would take anywhere between, let's say, 2.5 months to even, let's say, 6 months or more for a complete data lake implementation, including your platform setup, as well as your ingestion pipelines, quality, security, and even maybe a one-off or a two of business use cases that you would want to implement. If you look at it from a cloud perspective, setting up of the hardware infrastructure may not be required, and the setup could be fairly easy. It could happen in few days or a week, but essentially everything depends on the data that you would want to ingest and essentially the volume of data. So just to give an answer in a nutshell, anywhere between, let's say, 2.5, 3 months to 6 months or upwards, depending on different organizations.
Thank you, Parag. So we have just about at the end of the session. So thanks again, everyone, for joining us today for the webinar, and hope you all have a great day ahead. If there are any questions that we didn't get to, we will share the answers along with the recording of this webinar. You may also email us at any time with your questions to info@appstechcorp.com. So thank you all again, and have a great day.
Thank you, everyone. Thanks a lot for attending.